Hello, everybody. My name is Faris Tabit. I'm a graduate student at the University of Washington, and on behalf of my peers, I'll be presenting our OSM network connectivity system. Routing engines and navigation services are among the many applications of OSM data. But for these services to work correctly, the underlying road network data must be as accurate as possible. This means that ways should be correctly connected, road directions should be respected, turn restrictions should be recorded, and so on. Being an open license project with around 7 million users, contributions are far from lacking. Every day there are about 3.5 million map changes, and with such huge numbers, errors are bound to happen, and in fact often do. This is a problem. It's no surprise that wrong data will lead to wrong results, and this is no exception when it comes to routing and navigation. The more errors in the underlying data we have, the less accurate our routing services become. But why are we even talking about this? Should we even care about connectivity? Well, yes, we absolutely should. Having complete road connectivity has lots of important impacts. It reduces travel time, saves money and resources, increases routing options and modes of transportation, improves reachability, and distributes traffic density. These are just some of the many benefits of having complete road connectivity. With all that said, this problem is exactly where our system comes into play. It provides adaptable solutions to achieve road network connectivity. Given OSM data from any region desired, our system is ready to go. It can automatically detect incorrect connections and allow for a fast and convenient way of fixing them. It can also detect the disconnected parts of any desired road network and suggest a fix for achieving complete connectivity. To our knowledge, this system is the first of its kind. It saves countless hours of manual work put into detecting errors and suggesting fixes, and it's designed to automate lengthy, complex, and tedious processes. Now let's jump into the interesting part, our features. First up is finding incorrect connections, which are defined by nodes that connect two or more incompatible road types according to the OSM documentation. Finding incorrect connections not only helps the user sustain awareness about OSM data error, but it also saves man hours on maintaining that data integrity. This is done by automatic error detection and quick access to fixed solutions such as OSM ID and JOSM. Now, for some numbers, our system was able to detect 2,041 incorrect connections in New Zealand's motorway and trunk road networks, as well as 1,060 errors in Fiji's primary road network. Now, let's talk about the core feature of our system, finding road network disconnections and suggesting a connectivity fix. Given any subset of road classes that make up a road network, we can effectively detect all the disconnected subgraphs in that network. So as you can see, these subgraphs are all part of the same road network, but they are disconnected. Once these disconnections are detected, the system runs an algorithm inspired by breadth first search and Tarjan's strongly connected components to find an optimal way to connect these isolated subgraphs and achieve connectivity using the least amount of nodes or junctions possible. So the graph you see on the right is the result of fully connecting all the subgraphs you see on the left. It's a strongly connected component, meaning every vertex is reachable from every other vertex. The system allows you to visualize any road network, so you can pick any OSM road class and see what its road network looks like on the map. Another feature we have is allow listing errors, which was previously called whitelisting errors. This allows a user to hide an incorrect connection from other users, which is useful when you intentionally want other editors to ignore a specific error. Finally, the system has a very powerful download option which lets the user download every fix or error that is visualized by the system in the form of JSON files. Now, without further ado, let's jump into a demo focusing on New Zealand. Okay, so this is the landing page of the system. So as you can see on the left, I have a menu bar with all the different features I have. So right now I have preloaded the trunk road network graph, as you can see in red, but I can just decide to uncheck that. And from there, you can basically do anything or visualize anything, disconnections, you can visualize the connectivity fixes. So if I click on that, it'll load the fully connected graphs of New Zealand. So as you can see, if I hover, it'll give me more information. And of course, I can download everything that I'm seeing. If I click on that, it'll download a folder containing all JSON files of all the fixes and all. And of course, this is generic, so I can go to Fiji Islands. I can choose to visualize incorrect connections. If I click on one, it'll tell me more information. I can open it in IDE or I can whitelist it. And basically, in a nutshell, that's it. Thank you guys for watching.